Swayam Prabha. Digital India. Educated India.
One problem I am going to do is prove that A dot B cross C is same as C dot A cross B is same as B dot A cross C. All right. So, let us do that. Let us take A dot B cross C, which is going to be nothing but A I B cross C I summation over I by definition of dot product, which I can write as summation over I A I epsilon I j k B j C k. Right, and then I am summing over j, I am summing over k. So, A dot B cross C is equal to this. Now, let us see what do we do next. Next, what I can do is I can change the orders. Let me write this in the form of summation j summation k. I can sum in any order I like, this is commutative, I B j epsilon I j k A I C k. All right. So, now I will sum over B j later, and I will first sum over I and k. So, what have we got? We have got A dot B cross C is equal to summation over j B j epsilon I j k A I C k. I am now going to use the property that epsilon I j k, this is another property which I did not say in the beginning, is always minus epsilon if I switch two of the indices j I k. Okay. So, I can write this as summation over j with a minus sign B j epsilon j I k A I C k, which is nothing but equal to summation over j B j times A cross C j component with a minus sign, which is equal to B dot A cross C with a minus sign. Now, since A cross C is equal to minus C cross A, I can equally well write this as equal to plus B dot C cross A. So, that is the answer. A dot B cross C is same as B dot C cross A. It goes in the cyclic manner, right. So, A dot B cross C is same as I bring C out dot A cross B is equal to B dot C cross A. What I wrote in the beginning of the previous page is not correct. So, you can see how easily I could prove it. Let me use another problem where I will use these symbols. Let us see what A cross B cross C is, how it can be expressed easily. I am going to show that this is A dot C times vector B minus A dot B times vector C. Let us see how I can do that. So, let us take the ith component of A cross B cross C. This is going to be equal to summation over j and k epsilon I j k A j times b cross c, which is another vector, is kth component, which I can write as summation j k epsilon I j k a j. And how do I express the kth component of b cross c? It is going to be epsilon k L m b L c m, and I am going to sum over L and m also. This is the whole expression. Now, I am going to use some properties of epsilon products. So, let us first express this again. A cross b cross c, ith component, that is x, y or z component, is equal to summation j k L m epsilon I j k epsilon k L m a j b L c m. Notice that a j b L c m, there is no k in it. So, I can write this as epsilon j L m summed over, and then write summation k sums only over this I j k epsilon k L m a j b L c m. K sum is only here. Now, I know already, I gave you a property that epsilon k I j epsilon k L m summed over k is nothing but delta I L. First, the direct terms delta j m minus epsilon I m epsilon j L. So, I want to bring this epsilon k L m is okay, epsilon I j k into k L m form. Let us do that. Epsilon I j k, I can switch j and k and write this as epsilon I k j and pick up a minus sign, because now I have changed the direction in that circle in the clock. And again I can switch I and k and I can write this as epsilon k I j with a plus sign. So, now I have the sum is nothing but summation over k epsilon k I j epsilon k L m, and that is nothing but this delta function. Sorry, this is the delta function. I am sorry, this is a delta function here. All right. So, I can now easily express A cross B cross C ith component as delta I L delta j m minus delta I m delta j L from the previous place, A j L b L c m summation over j L and m. Notice I have to sum over j L and m, because on the left hand side there is only ith component. So, all j L and m should go away. Let us see that what is it. This is summation j L m delta I L delta j m a j b L c m minus summation j L m delta I m delta j L a j b L c m. Let us do the sum. Let us take the first term, summation j L m delta I L delta j m a j b L c m. When I sum over j or m, let us sum over m first. M delta j m is equal to 1 if m equals j and 0 otherwise. So, what this delta is doing is forcing m to be equal to j. So, this is going to be equal to summation j L delta I L m. When I sum over, it makes m equal to j. So, it is going to be a j b L c j. If m is not equal to j, this term gives me 0. Similarly, Now, if I take delta I L is equal to 1 if L equals I, 0 otherwise. So, this is going to be I am going to sum over L, I am going to get summation over j, delta I L forces L to be equal to I. So, I get A j B I C j, which I can write as summation j A j C j B I. Summation j A j C j, which is A 1 C 1 plus A 2 C 2 plus A 3 C 3, is nothing but A dot C B I. So, you can see that the first term is nothing but A dot C B I. Similarly, leave it for you, you can show that this will come out to be A dot B dot C I. So, you can see that the ith component of A cross B cross C is nothing but this dot product times B I, this dot product times C I. So, first component is going to be A dot C B 1 minus A dot B C 1, second component A dot C B 2 minus A dot B C 2, and therefore, in general you can therefore write A cross B cross C is equal to A dot C B vector minus A dot B C vector. If you are very fussy about the notation, then you can also write that A cross B cross C is nothing but summation I A cross B cross C ith component unit vector in the ith direction, and this is nothing but A dot C B I E I summation over I minus summation over I A dot B C I E I. Now, A dot C and A dot B are scalar quantities. So, they come out A dot C summation I B I E I minus A dot B summation I C I E I, and these are nothing but A dot C, this is vector B minus A dot B vector C, and that is your answer. So, what I have tried to give you through these symbols delta I j, which is in the matrix form an identity matrix 0 0 0 0 0 0, or symbol epsilon I j k, which is 1 if, let me make this symbol 1 2 3, if you make a combination of 1 2 3 in going clockwise, it is minus 1, if you make 1 2 3 combination in counterclockwise or anticlockwise direction, and 0 if any two subscripts are same, and epsilon I j k is equal to minus epsilon I k j, or it is also equal to minus epsilon j I k. Using this, how we can make vector operations simpler to handle.